Hey guys, so I just wanted to give you a couple little hints or tips for approaching these word problems. So for today, you are responsible for completing numbers 1 through 5, and then tomorrow I'll give you some tips for numbers 6 through 9. So this is linear and angular speed. Some of these are actually just going to be arc length, and the way that you're going to know the difference is if they're asking you how far something goes, but are not concerned with how fast it goes a specific distance, then that's simply going to be arc length. Um, so like for number 1, this is very clear that they're asking you for linear speed because they specifically ask for linear speed. So find the linear speed. So just go ahead and, use those formulas that we were using yesterday. For number 2, this says, gives you the radius, tells you at the rate the wheels are turning, how fast is the car moving. So right here, how fast is the car moving? So we know that this here is going to be our linear speed because whenever you are talking about how fast a car goes, that's always going to be expressed in like miles per hour, inches per second, feet per minute, stuff like that. So this is a distance over a certain time. And then they also tell you here, express your answer in inches per second. And then they also want you to express your answer in miles per hour. And those are the types of units that you always see on linear speed. So even they don't come out and say, what's the linear speed, then you should be able to infer that. For number 3, the minute hand of a clock, they give you the length of it. How far does the tip of the hand move in 15 minutes? And then how far does it move in 25 minutes? So we don't care about the rate. I mean, it's a clock. We kind of know what the rate is, right? So anytime it just says how far, this is going to be arc length. And then we did one on one of the arc length word problems on those worksheets we did last week that had a clock on it. So you guys should be, I think it was like how far did it move in like 35 minutes or something like that. So you should be able to refer back to that problem. And then this one here, the pendulum is swinging. How far does the tip move? So this again, this is just arc length. So how far does this tip move each second? It tells you that it goes 20 degrees in a second. So you can think about this as linear speed or as arc length because the unit is just each second, how far does it move in 1 second. So that one I thought was easier to think about as just arc length. And then number 5, so this is probably the hardest problem for today. We have these 2 pulleys. One of them has a radius of 2 inches and the other one has a radius of 8 inches. They are connected by a belt. If the 2-inch pulley is rotating at 3 revolutions per minute, determine the revolution. So we're going to be looking for our revolutions of the 8-inch pulley. So we want to know the number of revolutions that this guy is going to make. So the way you have to think about this problem is that this belt that's around here, this belt is moving like at a constant rate. So if you think about the speed of the belt, that would be the linear speed. So the linear speed of this guy and the linear speed of this one, they're actually the same as each other. So the linear speeds are equal. So if you set that up as the linear speeds being equal to each other, then you'll be able to actually solve for the number of revolutions here. So whenever you set your formula up, just call it X for your number of revolutions and then solve for X. So I hope that helps. I will post these solutions later and all my detailed work and stuff so you can see how they're done, but I want you guys to give it a try on your own first. So, and of course, email me for questions. Thanks.